In the name of Allah, the most merciful and the most beneficent. Hello everyone, welcome to Mathematics Basic to Advanced level. In this lecture, we solve properties of union and intersection. So properties of union, that is A union B is equal to B union A. First properties, that is commutative properties of union. Second, A intersection B is equal to B intersection A, that is commutative properties of intersection. Third, A union into B union C is equal to A union B into union C, that is associative property with respect to union. Fourth numbers, A intersection into B intersection C is equal to A intersection B into intersection C, that is associative property with respect to intersection. Five number part, that is A union into B union C is equal to A union B into intersection A union C, that is the associative union property, distributive property, union over intersection. Sixth number, that is A intersection into B union C is equal to A intersection B into union A intersection C, that is the distributive property of intersection over union. Seven number, that is A union B whole complement is equal to A complement intersection B complement. Eight number, that is A intersection B whole complement is equal to A complement union B complement, which is the so properties 7 and 8 satisfy the De Morgan's laws. Next, proof of one by one, that is proof of the De Morgan's law and distributive laws, that is first De Morgan law, A union B whole complement is equal to A complement intersection B complement. Let X belong to A union B whole complement, that is left hand side. So X does not belong to A union B, X does not belong to A, and X does not belong to B. So X belong to A complement and X belong to B complement. Next, X belong A complement intersection B complement. Second, A union B whole complement subset A complement intersection B complement, that is equation number 1. Now suppose that X belong to A complement intersection B complement, so X belong to A complement and X belong to B complement implies that X does not belong to A and X does not belong to B. So X does not belong to A union B. X belong to A union B whole complement. A complement intersection B complement subset A union B whole complement, that is the proper equation number 2. From equation 1 and 2 we can conclude that A union B whole complement is equal to A complement intersection B complement. Part number 2, that is A intersection B whole complement is equal to A complement union B complement. Let X belong to A intersection B whole complement. So X does not belong to A intersection B, X belong to A, does not belong to A, and X does not belong to B. Next, X belong to A complement and X belong to B complement, so X belong to A complement union B complement. A intersection B whole complement subset A complement intersection B complement, that is equation number 1. Now suppose that X belong to A union B complement, so X belong to A complement and X belong to B complement. So X does not belong to A or X does not belong to B. So X does not belong to A intersection B. X belong to A intersection B whole complement. So A union B, A complement union B complement subset A intersection B whole complement, that is equation number 2. From equation 1 and 2 it is verified that A intersection B whole complement is equal to complement of a set A union complement of a set B, hence proved. Next, third number, that is distributive property of union over intersection, that is A union into B intersection C equal to A union B into intersection A union C. Let X belong to A union into B intersection C, implies that X belong to A or X belong to B intersection C. If X belong to A, then X belong to A union B and X belong to A union C. And if X belong to B intersection C, then X belong to B and X belong to C, implies that X belong to A union B and X belong to A union C, implies that X belong to A union B into intersection A union C. So implies that A union into B intersection C subset into A union B into intersection A union C. That is equation number 1. Now suppose that X belong to A union B into intersection A union C. So X belong to A union B and X belong to A union C. Now there are two cases, either X belong to A or X does not belong to A. So if first, that is X belong to A, then X belong to A union into B intersection C. If X does not belong to A, then X belong to B and X belong to C. So X belong to B intersection C, implies that X belong to A union into B intersection C. In both cases X belong to A union into B intersection C, that is equation number 2. From equation 1 and equation 2, A union into B intersection C is equal to A union B intersection A union C, hence proved. Next, part number 4, that is A intersection into B union C is equal to A intersection B into union A intersection C, which is the distributive property intersection over union. So let's suppose X belong to A intersection into B union C, that is left hand side. So X belong to A and X belong to B union C. If X belong to A and X belong to B, then X belong to A intersection B, implies that X belong to A union A intersection C. So if X belong to A and X belong to C, then X belong to A intersection B, implies that X belong to A intersection B union A intersection C, implies that A intersection into B union C subset A intersection B into union A intersection C. That is the equation number 1. Now suppose that X belong to A intersection B into union A intersection C. X belong to A intersection B or X belong to A intersection C. There are two cases, that is first case number, if X belong to X belong to A and X belong to B implies that X belong to A and X belong to B union C. So X belong to A intersection into B union C. Case number 2, that is if X belong to A intersection C, so X belong to A and X belong to C implies that X belong to A and X belong to B union C. So X belong to A intersection into B union C. In both cases, X belong to A intersection into B union C. So A intersection B union A intersection C subset A intersection into B union C, that is equation number 2. From equation 1 and 2 we have A intersection into B union C is equal to A intersection B into union A intersection C. Hence proved. Which is the required solution? If you like my lecture, then please subscribe, share, like and press bell icon for latest update on my YouTube channel. Thanks for watching my YouTube lecture. Okay, Allah Hafiz.